In this video, we will demonstrate an OpenShift image-based upgrade. We will be upgrading from OpenShift 4.18.13 to 4.20.16. In order to demonstrate that this upgrade is non-destructive, we will be using a simple guestbook application that is installed. We'll start by creating a new entry in this application before upgrade so that you can see that the data is preserved from the beginning of the upgrade. With a new message created, we'll quickly log into the application and approve the message so that it will show up the next time we log in. With the application configured, let's go ahead and take a look at the OpenShift configuration itself and see the installed operators. As you can see, the lifecycle agent, local storage operator, and OADP operator are installed. Both the lifecycle agent and the OADP operator are required in order to do a successful image-based upgrade. Let's switch over to the command line and take a look at a few things from here. We'll do a quick check to see what version the cluster operators are at and to ensure that they are all showing as available and healthy. Now we'll take a quick look at the backup plan for this upgrade. You'll notice that we have two different backups and restores that are defined in here. One is to back up the state of the ACM clusterlet. The second is to back up the application itself and all of the different objects that create and make the application work. In order for the image-based upgrade to work, we need to take that backup set of instructions and create a config map from it. Now let's take a look at the definition for the upgrade itself. You'll see that we are upgrading to 4.20.16 and we have defined an image that will be used in order to do that upgrade. You can define things like a special pull secret if that is required. You can also configure additional manifests as well as information around rollback. In this case, we'll use the example file and apply it to the cluster. We'll use the command ocdescribe image-based upgrade, and we take a look and see that in the current state it is set to idle. We'll now use the ocpatch command to change it from an idle state to prep in order for it to start the preparations of upgrading the cluster. At this point, the cluster is downloading all of the required images that are necessary in order to do the upgrade. This process can take a little while, but is completely transparent, and everything will continue running in your cluster during this process. Once the prep stage is complete, we'll move it into the upgrade stage. We will do this using the ocpatch command again and change prep to upgrade. During this part of the process, the server will reboot. This will cause downtime for any hosted applications. The process itself during the reboot will depend on how long it takes for your physical hardware to reboot. Once the cluster has finished its reboot cycle, you'll be able to connect to the server again with the OC command, and you can continue to watch the status of the upgrade process. Once the cluster stabilizes, it will go ahead and it will restore all of your application data, including all of the definitions that make your application work. Once the restore process completes, the upgrade is completed, and you can go ahead and use your cluster that has now been upgraded to the newer version, in this case 4.20.16. You can see that the next stages are both idle and rollback. First, we'll go ahead and we'll test to ensure that we can connect to the cluster and manage it from the console. Now that we've validated that we can access the console, let's go ahead and refresh our application and attempt to access it and validate that the data is all there. As you can see, our data is still there. The message that we put in at the beginning of this video is there. So we have successfully upgraded the cluster, and we have ensured that our application stayed up and we preserved all of the data. The last thing that we need to do is to change the stage from upgrade to idle to finalize the upgrade process. Let's talk briefly, however, about what would have happened if something didn't go right with the image-based upgrade. Let's pretend that after the process had completed and the cluster was back up and running, and at the idle rollback state, we checked and connected up to the cluster, only to find that the application is no longer working. Instead of going through and troubleshooting the application, let's go ahead and use the rollback feature and roll back the upgrade to our previous state. Switch back over to the command prompt and we'll use the same patch command that we've been using before and change upgrade to rollback. We'll use the OC-describe command to take a look at the steps, and we can see that the rollback is now in progress. Just like the upgrade process, the server will need to reboot in order to switch back to the old version of OpenShift. With the reboot complete, we can check from the command line to see that the rollback has gone to a completed stage and that the next valid step is idle. If we move over to the UI and refresh, we'll see that we are now connected to the older instance of OpenShift. Now that we've validated that the original version of OpenShift has been restored, we can go over to the application, refresh, and see that the application is now back and working again. And we could take time to figure out why the upgrade may have failed or why the application didn't work in this upgrade scenario. And this concludes the demonstration of the image-based upgrade process.